So as we talked about, the test planning will be something for a different class. That's more of a testing class, and that's a bigger picture there. Um, what we want to focus on here is that specific test case development. What do I do to create a test case? So first of all, let's start with what are test cases? What do they mean? Well, a good test case is very explicit directions on what to do. For instance, first job I ever had, I was a software developer, designer, architect, whatever, not architect, excuse me, engineer, whatever you want to call it, working on an embedded systems project. We had a software quality group that did not write test cases. What we had to do as the software developers, I wrote the code, and then I also wrote test cases with very explicit instructions that would be handed over to the test engineers. The strategy here being independence of execution. As a developer, I knew what to test, but wasn't necessarily going to test it myself because we wanted independence of execution. So I had to write down, press this button, press that button, input this, plug it in here, run this data to post-process there, all that sort of stuff. And so literally, at one point I had a big discussion because it said press the on button. And press the on button, O-N. But on the device, the physical device, it was capital O, capital N. And so the question was there going to be ambiguity on whether, when I said the on button, if that was going to be interpreted as the big button that said capital O, capital N. And I was young and I was very frustrated. Like, oh, come on, how is it not? And these days, I kind of understand where you just want to be really explicit. Making it capital O, capital N, nothing hurts by doing that. And it certainly matches it better. And conceptually, it was also the on button. So, it doesn't matter in the slightest, but that was the level of detail that we wanted to talk at. We wanted to know exactly which buttons were going to be pressed and what they look like. What's missing inside of there is the independence. If somebody else writes the test, you get another set of eyes on it. But whether you are the other set of eyes or not, whether you are running the test or not, we want to know explicitly what steps are you taking. What buttons are you pressing? What values are typing in? And then what's the expected result of having hit that button or typed in that value or whatever's happening on the screen or whatever. We want to be able to know very clearly a priori is the fancy term, before it happens, what was supposed to happen, what was supposed to be expected to happen. So not all test cases need to be that formal. You could also just give kind of a general framework. You can kind of make it up as you go. It certainly is less planning if you do that, but it's hard to know what the heck happened. So you don't necessarily have to get to that level of detail. I've been to projects where it was like, okay, we have these test engineers. They're going to just go off and play with the system and see what they come up with. And what constantly happened on said project when we did that was we said, well, we tried to recreate that. We couldn't. So what were you doing when this happened? I actually had an interesting conversation to say, hey, what browser were you using when you did that? And they said, browser? What does that mean? They didn't necessarily know what a browser meant, which makes the word engineer a little bit hard to use at that point. They were testers at that point. So that's where we prefer formality. We want to have a known and common approach to what our test cases are going to be. We want to know what the system configuration is before we start. We want to know what the actions were taken inside of there. We want to be able to have very clear expected results, or even better, automate that whole process. So when I want to run a test, I press a button, and you can do this even with graphical user interfaces. It will simulate mouse clicks and key presses and enter values and screen scrape to see what the values showed up on the other side, and then give you answers. And particularly with websites, it's really easy to do that. You can even check formatting things on websites to some degree because of the nature of the HTML code coming back. So automating tests really gives that level of formality where I know before I even think of running my test, what my execution plan is going to be. So to do that, though, we have to start with a very clear scenario. And so the scenario is that what if plan. So little Sally wants to use this system, and her birth date is 1/1/2000, and she has 15 Barbies she wants to buy and puts them in her shopping cart. And when she hits checkout, the price should be $150.72. And so on and so forth. So very, very clear, very, very exact story. It's not just like I add some stuff to the cart and see if it adds up. Well, see if it adds up. Well, what does that mean? What value should be there? I mean, can I do it by hand and trust it, or should I, have something really clear on what's supposed to be happening? So, imagining scenarios can be easy or challenging depending on how you capture requirements. So in traditional requirements, you have to connect the dots. Basically, the testers end up doing the job separately from the developers of figuring out what the system flow should look like. That might be good, that might be bad. I mean, if the developers and testers have a different flow, somebody has to go back and fix it later on. Or what happens is the testers wait until the developers finish the design to tell them how things are going to flow, and then they start their tests later. Where if you have use cases, your test scenarios are basically defined as the flow in the use case plus some data. So if I can figure out what the steps are, what the user does, all I have to do is figure out 2 or 3 or 10 different sets of data that I can plug into that use case flow and be able to pull the data out there. So our job is really just that data generation and the calculations by hand and stuff that's going to go forth. So the scenario then, in either case, whichever way I do it, needs to be very clear about having the steps the user would take, the data the user would provide, and the expected responses. So the funny thing is, the steps the user can take might be the same for 5 or 10 or 20 different test cases. Because I go to the system, I log in, I click on my order, and I see my order, and I click on make return, and so on and so forth. That could be the steps. Well, in one case, I could have a bad username password, and I have a test case right there. In another case, I have no orders. That's a test case right there. In another case, I have an order, and the items pass the return date. In another test case, I have an order and it's fine and the item is returnable. In another case, the item is returnable but out of stock right now. Again, the user can take all the same steps, but the expected values would change based off of the different data that's being put in. So each set of data has an expected response that's going to be out there based off of the configuration that is. And so some of that's going to be outside the control of the user. If I'm doing a return on a product item and it's out of stock, I can't know that or do anything about that from the user screen. That must be set up in the database and must be set up. So I either have to pick a product that I know I'm going to keep out of stock, or I have to manipulate the database in the back end to make it out of stock, or. There's many different strategies of how to design that, but how do I even know that I need to design that until I've come up with these test scenarios? And the only way to know what all the different scenarios are about is what kind of data gets plugged in. So I'm trying to make a case for you that while it takes more time, driving out the exact data and expected responses helps drive out the test design. The test scenarios are essentially the requirements for the test design, which then lead to your test implementation. So all of those different data scenarios then lead to different scenarios like this. Don't have to document exactly like this. This is a table-driven format, but you can see step 1. I have this action that I'm taking as a tester. I'm going to provide specific data here. As you can see, I'm putting very specific names inside of there. But I can also be flexible. You see, in one case, it says date is today. Today is fine. What is today? Well, whatever the date is. It's not an explicit date because maybe if I put in January 1st, it becomes the middle of the year, and then something hey, you can't order something after 6 months or something like that. So it's okay in some cases to have relative data or data that's like, hey, just put in this thing. But then, the expected response should accommodate that. So, the data matches between step 1 and step 2. Okay, so I don't have to type the data again, but we want to say, okay, it's Boba Fett action figure, Star Wars toy, $7.99 is the price, and the date is today. What is today? Oh, okay, yeah, that's today's date. That still matches. Sometimes in test scenarios like this, you'll actually have a place where you write in values that you type in. So you keep a piece of paper or electronic document that talks about each test run. So particularly if the data is dynamic, you'd have to do this. And again, that project I talked about before, when we wrote our own test cases and somebody else ran them, we had to leave blanks there so somebody could fill in what actually happened and we could post-process it later on. So all of these test scenarios derive from the design of our system. It could be something high level like activity diagrams or behavioral diagrams. It could be down low like our code, but there's flow that needs to happen inside of there. And so the more logic you require up at the requirements phase, and this comes from the use case, the more tests I can see. So if I write a use case and I know I have a primary flow and an alternative flow and some exception flows, and maybe there's a few of them out there, each of them basically amounts to a new test case that needs to happen. So view it this way. This could be an if-then-else statement. This could be alternative flows. So we have this branching network of things that could happen. And so our primary flow of our use case could look like this. So the user enters the system. If they log in successfully, then I present them with their order history, and then I press the return button, and I end up, okay, your item is being returned. Here's your shipping label, go. A, B, F is the primary flow. Well, any of these flows could happen as well. So on A, maybe I don't log in right away. I go to down below, which is the supply your secret answer question thing, and then I reset the password on C, and then I can do. Then I'm logged in, and then I can hit my return button, and then be done there. Or maybe there's some other flow that's going on inside there. But every time we add in an alternative flow or an exception flow, I end up with a different path. So this little 2 or 3 decision flows things inside of here all of a sudden comes up with, you can count the colors here, 1, 2, 3, 4, 5 different paths, 5 different test cases that would have to come from this. And so that's what we want to try and get to here a little bit. Not so much that I want you to explicitly drive out 5 different test cases, but I want you to identify that there are 5 different test cases. I want you to give details on maybe one of them, but recognize the fact that I need to really have 5 different data sets in order to be able to fully test this feature. And so we'll work on this and we'll play with this a little bit more, but that's the type of thing we're going to be looking at as we go through our system and understand a little bit more about what it is to create test cases.